Hello and welcome back to the Coking.com channel. I am here at VEGA Americas in Ohio with Jeff Bowers. He's the radiometric product manager. And he's going to be explaining us a little bit more about the coke drum continuous level measurement. So Jeff, tell us a little bit about the history of VEGA and your background.
Yeah, so my role here as a product manager is identifying features and requirements of our radiometric devices as required by our customers. One of the specialty systems that we do a lot of is delayed coker continuous level using gamma radiation. We have about 350 drum installations in the world. We've been measuring delayed cokers for about 25 years and about 10 years using our latest product.
Excellent, excellent. Well, thanks for that history. So one of the things we wanted to talk to you and the audience about today was the fact that if you notice looking around this room, there's a lot of yellow things. But me, being a little bit older, I remember when this technology came out about 20 years ago, everything was blue. So tell us a little bit about this recent transition.
Yeah, so our new device is what's known as the ProTrack series of equipment. It's really a smaller, more modern piece of equipment. The primary thing is the electronics package has been upgraded to keep it modern and with the current times of production.
So basically, if you're out and your coke drum and you have one of these systems, and if it is blue, it is the old system and it is now obsolete, and that's the message you want to get across. If you have a yellow system, you have been upgraded, thumbs up. So let's talk a little bit about what's changed in the hardware of this gizmo. So in the old Gen 2000 system, this is more or less what was on the inside of the system. It's a typical circuit board arrangement. This is where the scintillators would come in.
Yep.
And so tell us a little bit about what you've upgraded.
Yeah, so you can see in the old board production, everything was open. What we have now is a modular potted electronics that survives the temperature and humidity and environmental features much better than the old ones do.
That's good. Well, I know that we have historically had some challenges with temperature.
Yeah.
So this particular device, if it was mounted physically too close to the coke drum being 800 degrees Fahrenheit, 400 degrees Celsius more or less, it still with all the insulation gets hot and that can damage this components. And so with this changes, you've made some...
Yeah, so the temperature is good, but I think in best practice, since we're using radiation as our measuring principle, you can mount this equipment roughly a foot off the drum and help natural convection and the radiant heat applied to the instrument go down.
Yeah, it definitely doesn't. It doesn't need to be close coupled. Good point.
Yeah,
good
absolutely.
point. So that's just a brief discussion about how their technology has evolved. Really, the core of this video, I want to talk a little bit about the measurement principle for gamma continuous level. So I'm going to grab our little props. If Jeff, you want to introduce us to what you have in the background here.
Yeah, so here's an example of a training vessel that we have here at VEGA. On one side of the vessel, you have source holders. On this particular vessel, you have two. These project the radiation beam at a right angle, a 45-degree triangle coming out and down from each source elevation. And as the fluid fills the process vessel, it blocks that radiation. So what our detector on this side here is receiving is that radiation signal. So on the inside of this flexible black conduit, you have scintillating fibers. So these receive the radiation signal and send light pulses along the fiber optic cable up to the sensing element. So as the material as the process material fills the vessel and blocks the radiation, the device knows it's lost some amount of radiation and it can interpret that into a process variable.
And one of the things I like to talk about in my training is that along this whole length, I mean, this is the scintillator that's in the tube. So if you've been in the field, you know that this little black snake exists in a big piece of conduit to keep it protected from the elements.
Yep.
But what's inside of here, this is the continuous level sensing fiber optic elements. And as the radiation goes in here, it causes a little flash, and those counts are aggregated up to measure the level, right? So
correct.
For your particular source, your particular drum, 12,563 counts means 0. and 0 counts means 100% level. But if anything occludes that radiation along this more or less
along the length of the
device, the system doesn't know if it's up here or it's down there.
Correct.
It just interprets that as less counts equals 5% level.
Yeah,
right?
or 10% level,
or whatever.
as it gets filled. Yeah,
as it gets filled.
Yeah.
So and then on the top of it, you have another little gizmo. What's that one?
Yeah. So this is what's known as a photomultiplier tube. So this is actually what's receiving the light signal from the fiber bundle. So you can imagine it oriented in such a way. So as you correctly said, it's receiving this from the entire length of the bundle, and it doesn't know where on the length it's coming from. But in our case, these can be as long as 23 feet. So you can get quite a bit of volume and quite a bit of space that one of these sensors can cover.
So I'm all about the delayed coker. It's our singular focus here. The level spans that we typically see in industry, if I travel around the world, I see 2, maybe 3, I would call this a string, more or less 20 feet in length.
Yes.
On a delayed coke drum. And so that's sort of like a quote unquote typical installation, but you can get varying lengths. Like I've seen little puck pieces that as small as 6 feet.
Correct.
You can be strategic about how long you want this to be.
That's correct. So we can make these in 1 foot increments, and we customize them to fit the desired measurement span from the customer.
Interesting. So I think this has been very informative. We now know that a gamma continuous level is something that is based on radiation. It's different than neutron backscatter. See our next video in the series, which we're going to talk about the differences between target switches and neutron backscatter. But gamma continuous level is something that's been around for more than 20 years, have 350 coke drum installations around the world. Jeff has given us just the tip of the iceberg of information here. If you'd like to learn more about this technology and delayed coking technology in general, I'd encourage you to visit us at RefCom every year. We're in Galveston, Texas in May. Jeff's going to be there, as well as other people from the VEGA team, and they'll be happy to give you all the details you need to know to help to optimize your system, keep it reliable, and potentially upgrade from the obsolete blue housings to the new ProTrack yellow housings. So if you can't join us at RefCom, please feel free to reach out to VEGA. Has reps literally all over the world, in every region of the world, and they probably have installs in your facility. So reach out to them directly, and I'm sure they'll be happy to help you as well. So thank you, Jeff, and we will see you at RefCom.